geometry students, to the second part of the homework help video. We were on number 17, so here we go. We are going to find the area of this, let's see, what do we have here? Parallelogram, I guess. Well, I'll tell you what, we're starting off with the right triangle right here, and we're missing a leg. So one leg is 4 square root of 2. The other leg we don't know, and the hypotenuse is 8. So if you square 8, you'll get 64. If you x squared is x squared. Now if you square 4 square root of 2, you square the 4, that's 16. You square the square root of 2. Anytime you take the square root of 2 and square it, you get the number on the inside. So that's 2. So 16 times 2. So you end up with 32 plus x squared equals 64. Okay? So subtract 32 from both sides, and you end up with 32. Take the square root of 32, and my pen is really messing up tonight, guys, so sorry about that. Take the square root of both sides, and you would get the square root of 32, which is the same thing as 16 times 2. Cross off the 16 and put a 4 on the outside, and you're left with a 2. So this length right here is 4 square root of 2. Alright? Now, does that help us or not? I probably just totally wasted our time in doing that. No, I did not at all. So that's our base. If this here is 4 square root of 2, then this down here is also, from here to here, is 4 square root of 2. So there's the base of my parallelogram. Now, the height of the parallelogram would go from here to here. That would be the height of the parallelogram from here straight down to here. So remember, if I extended this base of the parallelogram all the way out to here, the height would be this line here that goes straight down. Okay, so this line here again for the third time, this line here is the height of my blue parallelogram. So I should be able to find that pretty quickly, because and hold on one second, I'm trying to think to see if I have congruent angles here. Let's see. Yes, I'm pretty sure, guys. I'm going to get 7 square root of 2. Also, for this side right here, I think I have a 45, 45, 90 triangle. In that case, the 2 legs are congruent, but I'll go ahead and work it out just in case. So I'm trying to find this leg right here. So I'll have the height of my parallelogram. Alright, so I know the length of my hypotenuse is 14, and the length of one of my legs is 7 square root of 2. So I'm going to square one of my legs. We'll call my other leg x. And then my hypotenuse is 14. So if you square the 7, you get 49. And if you square the square root of 2, you get 2. So 49 times 2 plus x squared, and 14 times 14. I think it's 196, but yeah, 196. 49 times 2 would be 100. It would be 98. 98 plus x squared equals 196. And then if you bring that over to the other side and make it a negative 98, you're left with x squared equals 98. So then you have x equals square root of 98, which of course 98 is 49 times 2. Cross off the 49 and put a 7 on the outside. So we have 7 square root of 2, like I said before. So this distance from here down to here is 7 square root of 2. 7 square root of 2. Alright, so the base of my blue parallelogram is 4 square root of 2. The height of my blue parallelogram is 7 square root of 2. So the area is base times the height. So 4 square root of 2 times 7 square root of 2. 4 times 7 is 28. Square root of 2 times square root of 2 is just 2, which would be 56. So for number 17, 56 is the area of the blue, okay? And then students, very quickly we can find the area of the 2 triangles. The yellow triangle base times a height. A base of 4 square root of 2 and a height of 4 square root of 2, so 1/2 times the base, 4 square root of 2, times the height, 4 square root of 2. So 1/2 times 16 times 2. 4 times 4 is 16, square root of 2 times square root of 2 is 2. So 1/2 times 32, which would be 16. So the area of this triangle is 16. Now, the other yellow triangle has a base of 7 square root of 2 and a height of 7 square root of 2. So 7 times 7 is 49. Square root of 2 times square root of 2 would be 2. So 49 times 2, which would be 1/2 times 98. 1/2 times 98, which is 49. So the area of this yellow triangle is 49. So if one triangle's area is 16 and the other triangle is 69, add those together and you will get 65. So the two yellow triangles together is 65 square units, and the blue parallelogram is 56. Use ditto marks here, units squared. Alright, moving on to number 18. For number 18, let's see what we have here, guys. Let's go ahead and just get rid of this and make this bigger. And here we go. I have a yellow parallelogram. And let's see. Well, I'm trying to think if it's easier to find the area of the entire rectangle, the whole thing, and then subtract out the two blue triangles to find the yellow. If that's easy, well, let's do this real quick. If this is 12 here, then I know this is 12 here, okay? And if from here to here's 8, then from here to here's 8 also. So I have two identical triangles. This triangle here is congruent to this triangle here, okay? And so, to be honest with you, I think it's best to find the area of the blue triangles first. So area of this bottom blue triangle is 1/2 base times height. So 1/2 times my base times my height, which would be 48. So the area of the blue triangle is 48, which means the area of the blue triangle up here is 48. So the entire area of the blue area is 96 square units. So there's one answer, 96 square units, and that's for the blue area. Now, think about this, students, please. I'm so glad I did it that way, because now I can find the entire area of this whole rectangle and then subtract out 96, because 96 is the area of this blue triangle and this blue triangle here. So that's pretty easy to do. The area of this entire rectangle is length times width, 16 times 12. Length right here, length times width. So 16 times 12 gives you 192. So the whole area is 192. Now subtract out your two triangles. One's 48 and one's 48. And you're going to be left with 96 also. So 96 square units is also the area of the yellow parallelogram. Okay, that's how I would solve that one myself. Alright, okay, moving on. Moving on. Now, students, for numbers 19 through 22, the directions say to take 4 right triangles that are isosceles. Now, an isosceles right triangle means the two legs will be congruent, okay? And what we're going to do is we're going to make shapes out of these, which is good practice. It makes you think, okay? So they want us to come up with a square using these 4 right triangles. So, I think probably the best way to do this would be to, let's see here. I'm going to take this triangle and put it this way. I believe that's what I want to do. Almost. Let me turn it a little more. can and turn it like this. Yeah, there we go. Yep. And it won't be perfect, guys. You understand. I mean, my triangles aren't exactly isosceles. They're very close, but not perfect. So, and let's see, this one here would go like this. And then this one here, again, not perfect, but hopefully you get the idea, okay? And this one theoretically would fit right there. So there's our square, okay? All right, moving on to the next one, which would be a right triangle, a big right triangle, all right? Well, that shouldn't be too hard to do. Let's take one triangle and put it here. Let's take another triangle and put it here. Yeah, that should work really well. And then take this and flip it so that it fits right in there. Like this. Yeah, there we go. And then this, I believe, would go right here. There we go. There's a big right triangle. Okay. Next would be a non-rectangular parallelogram. So it's got to be a rectangle is a parallelogram. But they want a non-rectangular parallelogram. So it's got to be a parallelogram that's not a rectangle. So I think we want something like this. And then like this, which obviously my triangles are not very isosceles like. There we go, it's a little better. And then take this one here. And let's flip this one around this way. Alright. And then this one would go this way, slanted up like that. There we go. There we go. That's a pretty decent parallelogram. Not too bad, okay? Alright, and moving on to a non-square rectangle. Alright, so I want a rectangle that's not a square. So this might be the easiest one out of all of them. I mean, if you think about it, just take this one, take one of them, flip it this way, slide it right there, then take one and put it here, then take this one and flip it, and there's our rectangle. Okay, pretty much anyways. Alright, moving on to numbers 26, 27, and 28. Now that I'm turning back in my book now to the homework, the directions say to, hold on one second, okay, we're going to read in A, hare and hound's balloon race. One balloon leaves the ground first. The other balloons leave 10 minutes later. The hare lands and makes a square region as the target. The hounds each try to drop a marker in the target. Okay, so that's what we're trying to do here. Alright, so with that in mind, first of all, suppose that a hound's marker is equally likely to land anywhere in a rectangular field. That's 200 feet by 250, so here's the rectangular field right here. You know what, now that we've understood what they're doing, I don't think we'll need this probably again. If we do, we'll pull it down later. So what we have is a 200 by 250 rectangular shaped field, okay? 200 by 250. Now, the target is a 20-foot square, so we have a target in here that's 20 by 20. What is the probability that the marker lands the target? Well, first of all, the area of the entire rectangle would be 200 times 250, okay? That would be 50,000. So the area of this entire rectangle, 200 times 250, is 50,000, alright? Now, the area of the square would be 420 times 20. So now think about it, students. If we're talking about probability, that means you take the actual amount over the possible. That's how I've always taught probability. Actual amount that you're trying to find the probability of is this square right here. So you have a probability of 400 over 50,000, or 400 square feet out of 50,000 square feet. Well, cross off some zeros. You really have 4 over 500, which is 2 over 250, which was 1 over 125. And if you take 1 and divide it by 125, you will get 0.008, which is the answer. Or you can just take 400 divided by 50,000 and you'll get the answer, 0.008. Alright, not too bad. Now, let's go on to the second. Actually, I shouldn't have done that. Let's leave this part up. We'll probably need it. Now, let's go ahead and move on to the next problem. If the area of the target is doubled, how does the probability change? Well, let's see. Let's double the area. If the area is doubled, so now the area is 800. Got it? So now I guess it's 20 times 40 would work, something like that. So now you have 800 over 50,000. So instead of reducing, just take your calculator and take 800 divided by 50,000, and you're going to get 0.016. So it doubled. It went from 0.008 to 0.016. And if you took this times 2, you would get 0.016. So it doubled. Okay? So when you double the area, it doubles your probability. It gets better. Okay? Alright. And then lastly, number 28 says, if each side of the target area is doubled. So now we're going back to our original problem here, okay? And we're going to double each side of the target area. So if we double 20, we get 40. And if we double 20, we get 40. So we double this side, we double this side. You double each side of the target area. So now we have 1600 for the area. So 1600 divided by 50,000. I'm going to check it just to make sure we're doing everything correctly. So 1600 divided by 50,000 gives you 0.032. So it quadrupled. The original probability was 0.008. If you multiply that by 4, you will get 0.0032. So when you double the area, you double the probability. When you double each side of the target area, which really means you quadruple the area. Remember how the original area was 400? Remember that? 20 times 20, and now the original area is, now the new area is 1600. So when you quadruple the area, then you quadruple the probability also. Okay, watch that again if you need to, guys, but that's how you would solve those problems there. Alright, moving on to the next numbers, which will be numbers 29 through 32. Now, you learn more about this in pre-calculus, okay? And we kind of talk where this comes from. It's called Heron's area formula. Alright? And what it tells you is, it's basically another way to find the area of a triangle. Okay? Now, what you do, the area of a triangle equals this. It equals the square root of. And you take s times s minus one side times s minus another side of the triangle times s minus another side of the triangle. In other words, with Heron's area formula of a triangle, all you have to know are the lengths of the three sides. You don't have to know the height of the triangle. Just know the length of the three sides, and you can find the area. Now, the only problem is we don't know what S is. But if you look in the directions, it also tells you what S is. S is 1/2 times the sum of A plus B plus C. So let me walk you through the first one here, see if this makes sense. You have a triangle that has lengths of 6, 5, and 10. 6, 5, and 10. Okay, so first of all, we're going to quickly find S. 6 plus 5 plus 10 would give you 21. Okay, and 1 half times 21 would be 11.5. Alright, so all of your S's are 11.5. So now that we know what S is, I need to keep this formula just for a second, so I can copy that over for the next 3 problems. So S equals 11.5, okay? So with that in mind, everywhere there's an S, I'll put 11.5, so 11.5, and then we have 11.5 minus 6 minus A, and then 11.5 minus B, which is 5, and then 11.5 minus C, which is 10. So next I have the square root of 11.5 times 11 minus 6, 5.5 times 6.5, 11.5 minus 5 times 1.5. So with my calculator very quickly here, 11.5 times 5.5 times 6.5 times 1.5 equals 616. Square root of 616.6875. Take the square root of that number and you will get 24.83. Now it looks like I've made a mistake somewhere, so let me see if I can find that real quick here. Let's see, A plus B plus C, 16, 21. It'd be 10 and a half, wouldn't it, students? Okay, well that's alright. We all make little mistakes. We'll do this real quick. Your S would be 10 and a half. So let's quickly change that. Change that. Change that. Change that. So we'll make this 10.5, 10.5, 10.5, 10.5. So we have 10.5 times, let's see, 4.5 times 5.5 times 0.5. Alright, let's try that again. Hopefully I've not made another little mistake somewhere. And that is correct, 11 point. You would end up with the square root of 129.9375. And then take the square root of that and you will get 11.4 rounded, okay? So that's how you use Heron's area formula of a triangle. It can be really helpful when you don't know the area, okay? Let's try a couple more of these very quickly. Alright, number 30, same thing. So we'll do this pretty quickly here. First of all, let's solve for S first. So we have that taken care of. So S would be 1 half times 1 plus 6 plus 7. Actually, it's feet, inches. So 1 foot would be 12 inches. Alright, so it's 12 plus 6 plus 7. Alright, so 25. So 1 half times 25 would be 12.5. Why they keep giving us decimals, I don't know. That's pretty dumb, but that's fine. So 12.5. So S equals 12.5. So we have 12.5 and then 12.5. I'm going to do this in my head, guys. 12.5 minus 12 would be 0.5. And then 12.5 minus 6 would be 6.5. And then 12.5 minus 7 would be 5.5. Alright, square root of that. Let me grab my calculator real quick here. 12.5 times 0.5 times 6.5 times 5.5. We get the square root of 223.4375. And so the square root of that would be 14.94, or 14.9 would be acceptable. 14.9. Okay, moving on to the next problem. We're not going to area one way, again using Heron's formula. I'm not really interested in proving it by using this formula here. It does work, so here we go. Let's again practice using Heron's formula. So S equals 1/2. We have an equilateral triangle whose sides are 2. So 1/2, 2 plus 2 plus 2. Now S would equal 3. So we'd have 3. 3 minus 2 is 1. 3 minus 2 is 1. 3 minus 2 is 1. So we have the square root of 3 times 1 times 1 times 1, which would be the square root of 3, which would be whatever that would be. Let's see, square root of 3 would be 1.73. So equals approximately 1.7 square units. Okay. Alright, moving on to number 32. Same thing, we're just going to find the area using Heron's formula. And so let's pull this up here, and let's pull this over here, and let's solve for S quickly. So it'd be 1/2 plus 1 plus 1 plus square root of 2. That'd be 1/2 times 2 plus square root of 2. And let's get a decimal for that to make it a little easier. So 2 plus square root of 2. 2 plus square root of 2 would be 3.14 times 1/2 would be 1.7. Oh, so S equals 1.7. So we have 1.7 times 1.7 minus 1, that's 0.7, times 1.7 minus 1, that's 0.7, and then 1.7 minus square root of 2. So 1.7 minus square root of 2. Okay, S would be 1.7, and C would be your third side. So 1.7 minus square root of 2. 0.29. And the square root of all that. So 1.7 times 0.7 times 0.7 times 0.29 would be the square root of 0.24157. Alright, and so then if we take the square root of that, we will get 0.49, or 0.5 basically is the area of the triangle. Okay, 0.5. Alright, hope that makes sense, guys. Moving on to 33 through 38. 33 through 38, let's find the area of these triangles. First of all, let's start off with triangle AEC. So A, then over to E, then up to C. So we know our base is 1, 2, 3 units. We know our height is 1, 2, 3, 4. So we have a base of 3, a height of 4. So 1/2 times base times height would be 6. So the answer to 33 would be 6 square units. Okay, just found the base and the area and took 1/2 times base times height. Alright, CED, so here's C, over to E, over to D, so there's CED. The height would be 1, 2, 3, 4. So the height is 4. The base would be, start here, never count where you start. Okay, so you would start here and not count. You would go 1, 2, 3, 4. So you start here, 1, 2, 3, 4, 5, 6. So we have 1/2 times a base of 6 times a height of 4, and you'll get 12. So the answer is 12 square units. Alright, let's take a look next at number AEB. So A over to E, and then up to B. So there's the triangle AEB. So my base is 1, 2, 3. My height is 1, 2, 3, 4, 5, 6. So I have 1/2 times my base times my height, and that would give you 9. So the area would be 9. Alright, let's try number 36. Triangle ACD. ACD. So A up to C, down to D. So triangle ACD. Well, first of all, guys, this has to be a perpendicular line. It's that y-axis that goes right up and down. So your height is 1 2, 3, 4. So your height is 4. Your base is, start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 1/2 times your base times your height, okay, which would give you 18. So your answer would be 18 square units. Alright, let's try number 37. Triangle ABC. So A down to B and then to C, okay? Now, let's think about this for a second. Let's look this through, okay? Here's what I'm thinking and see if this makes sense, guys. Okay, watch this carefully. I think I already found the area of this big triangle AEB right here. Triangle AEB. I'm sure I did somewhere. Yeah, here it is right here. And then I'm pretty sure, now see if this makes sense, watch carefully. I'm pretty sure I already found the area of triangle AEC somewhere. Yeah, right up here. So now see if this makes sense, students. Okay, look. Watch this carefully. If I find the area of this whole big triangle AEB, okay, and then I subtract out triangle ACE like this, if I subtract out this triangle here, AEC, then I'm left with triangle ABC, which is what I'm trying to find. So what I'm trying to show you is, if I take the big triangle AEB and I subtract from it triangle ACE, that's going to equal triangle ABC, which is what I'm trying to find. So the area of triangle AEB was right here, 9, minus the area of ACE, or AEC, same thing, AEC, ACE, same triangle, is 6 units, and that should equal triangle ABC. So 9 minus 6 is 3. The answer should be 3 square units. Alright, moving on to our last one in this section, triangle ABD. So from A over to B and down to D. Now here's what I want to show you, students. We want to find this entire area of this whole big triangle, okay? Now that's really simple to do. We can do that pretty quickly, but there's also, we can do it because we can count up and find the height right here. That's pretty easy to do, and we can definitely count over and try to find the base. That's easy, but another way to do it is this. Watch this, students. With green, I'm going to highlight this triangle here. And then with blue, I'm going to highlight this triangle here. I've already found those two triangles. I can add those two together, and I'll have the whole area. Okay, see the green triangle, ABE. Where's that add up here? Here it is, ABE, or AEB is 9. So this green triangle has an area of 9. Now the blue triangle is triangle EBD. And maybe I didn't find that already. I thought I did. EBD. No, I guess I didn't. So my idea would not work that well. I was just trying to save time and say, let's take this triangle here, and then triangle EBD. I'm not seeing that anywhere. Nope. And then add the two together. Okay, that's fine then. So here's what we'll do. We're trying to find the area of this triangle ABD. So let's just do it the old-fashioned way. Let's find the height. The height is 1, 2, 3, 4, 5, 6. So the height is 6, and the base is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1/2 times the base times the height. 1/2 times 9 times 6, which should give you 27 square units, and it does. Okay, oops, didn't mean to do that. So there we go. Not too difficult. Let's continue on. Alright, students, now a couple quick problems here. Number 39. Well, I just revealed the answer to you accidentally, but that's not a big deal. We still have to know how to work this out. So here we go. It says here, students, IK is 3EG. So IK is bigger because you have to take 3 times EG to give you IK. So let's just say that EG is 2. I'm just going to make a number up, okay? That would mean that IK is 6. Got it? Because 3 times EG gives you IK. Now, JL equals 2 of the FH's, so FH is smaller. It takes 2 of those to equal JL. So let's say FH is 1. So that means JL then would have to be 2. Now find the area of both triangles. This triangle over here would be 1/2 times your base times your height, which would give you 1. So there's your area 1. Now over here, for the area of this triangle, we'd have 1/2 times the base times the height, which would give you 6. So what is the ratio of the area of the bigger triangle to the area of EFG, a smaller triangle? Well, the ratio of the area of this triangle to this triangle would be 6 over 1, or 6 to 1, or 6.1. Either way, it's 6, okay? 6 over 1 is 6. Okay, not too bad. Alright, number 40. Now guys, come on, think about this. A lot of you would have chosen not enough information, probably is what you would have thought on this one. But learn to think about stuff, okay? Learn to think this through. Look. You know this length here is 4. You know this length is 3. Now I have a question for you. If I were to draw a right triangle right here like this, okay? Isn't this my hypotenuse? Yes, it is. Isn't the hypotenuse always the longest side of a right triangle? Yes, it is. So I don't know what the height is going to be, this line that comes straight down, but I know it's going to be less than 3. It's going to be 2 point something or whatever. It's going to be less than 3. So if I take 4 times 3, that's 12. So I know my area has to be less than 12. It has to be less than 12 because this length here is less than 3. So when I go to find the area of this parallelogram, and how do you find the area of a parallelogram? Simply base times height. Well, the base is 4. If this is 4, then this would also be 4 right here. Okay? So your base is 4. So you would take 4 times your height, which would be 2 point something, but it's going to be less than 12. We know it can't be greater than 12. We know it can't be equal to 12 because this side here is less than 3. So it can't be determined. There is one answer that works. It's less than 12, okay? Hope that makes sense, guys. My only problem is really this is a poorly written problem because nowhere do they say in the directions you have a parallelogram. So really, you have to assume you're going to use base times height, which is okay, but it's not the best. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.